Hello and welcome back to Steam It with Steve. Today's we're going to go through how to do flip-flops and how to design your own little circuits inside of Logically. So to start, we're going to construct the logic circuit from a truth table, and the easiest way of doing this is if you're given the truth table with all the outputs, you basically just build the ones with the ones in the Y output. So you make an AND gate that joins the inputs that come with it, and then basically join those together into the rows. So anytime there's a 1 in that last column, you basically put that into the different layers and then repeat those steps until you've got the diagram. So if we were to construct this truth table from here, basically we've got A, B, C, D, E, Z as the output, and then what happens there is we test to see whether or not that worked, and then that's where it's sort of connected in, and we're all good from there. So what is a flip-flop? Well, it's not a pair of thongs for those in Australia. So that's a bit of a bad joke. No, it's not that. It's used for circuits when you have something like a security system or a trap door or something where something breaks and then you want the system not to be able to reset until you press that reset button. So the easiest way to think about it is you're basically building the circuit and like that. So the easiest way of doing it is something like this, which is really cool. Have a look at that link. But the idea is the circuit, the input for the AND gate of each of the two AND gates comes back into the input of the other gate, which is a bit of a head spin. And what you'll see when you run the simulation is basically if you press the set button, no matter how many times you press the set button, it will not turn the circuit off until you press that reset button. So it's kind of like a trap door. So as soon as you press the set, it's on, and no matter what state you change the set on, it doesn't change that, which is kind of cool. So flip-flops are also known as latch circuits, and they take in an input value that then changes the way that it's either on or off, which is what the Q naught and Q is. So you can either use two NOT gates or two NAND gates, and the same thing works. So a flip-flop is a bistable device. It only has two stable states. It can remember and store binary bits of information, and the flip-flop is changed to a 1 and only changes back to a 0 once the reset has been triggered. Once it's been put to 0, it can then only change to 1 once the input has then been changed again. So it's a little bit different in the truth table as it has 5 different outputs depending on the time of that you've done. So if you have if you press S at the start, it turns the system on, and if you turn it off, it doesn't matter, it saves the state. Now this is pretty much how memory works. So your computer, you might have heard of a thing called RAM. As long as there's power inside of it, it stores the way that the states are being stored, which is kind of cool. You can build this in logically pretty quickly like that, and you can then play around and press those buttons to see what it looks like, which I would highly advise. The more you play around with this, the easier it is to see the patterns. So there's a flip-flop. Explain how the properties of the circuit make it suitable for this purpose. And then there's an example. A flip-flop is used in the storage of bit in memory, having the output from the first NAND gate feeding into the second NAND gate and the output from the second into the first. This allows the circuit to maintain its state until deliberately reset. So that's the whole point. It's like a trapdoor. If you press the turn on button, it can't reset until you press the reset button. So we went through how counting works. There's a pretty cool thing there. And then there's a ripple counter option inside of Logically, which I would highly recommend playing around with. So then you can see this in action with all the different states. So explain that flip-flop circuits are used in storage and shifting of bits, and in memory, how you may include a diagram in your response. So then I've got the answer there. The feedback loop in a flip-flop circuit makes it a bistable device capable of storing 1 bit. Several flip-flops put in together, like what you should have just seen in the latch design. By linking the output from one flip-flop to another, the bits can be shifted between one another, effectively multiplying or dividing. There's another question, so pause the video and see if you can have a go. So outline the purpose of a flip-flop. Describe the operation of a flip-flop with 2 inputs and 2 outputs. And there we go. So a flip-flop is a basic circuit for storing information in a digital computer. There are several types of flip-flops and circuit designs, but there are 2 characteristics shared by all flip-flops. A flip-flop is a bistable device because it has 2 different ways. That is a circuit that with only 2 stable states, 0 or 1. It can remember or store binary bits of information because of the bistable characteristics. A flip-flop has two output signals, one which complements the other. And then down the bottom for the next part, the flip-flop responds to inputs. If an input causes it to go to its one state, it will remain there and remember a 1 until some signal goes to a 0 state. Similarly, once placed in a 0 state, it will remain there until told to go to a 1 state. This simple operation provides the basis for information storage in a digital computer. The student may also respond to the question diagrammatically. So there's all the inputs, and then there's all the outputs with the different states. And then there's a cool little video if you need a bit more hand. So here's another question. So in a food processing plant, a sensor monitoring the temperature in a pressure cooker. If the temperature goes above 300 degrees, power to the cooker is switched off. The sensor produces a 1 if the temperature is above 300 degrees, otherwise it produces a 0. A master switch will return the monitoring system on and off. 1 means the system is on. If the cooker power supply receives a 1, the cooker is on, otherwise it is off. The logic diagram has been designed and implemented below. A flip-flop has been inserted into the circuit in the position shown in the arrow. Describe how the flip-flop affects the operation of the system, including the answer description of how flip-flops work. So a flip-flop is a bistable device. Hopefully you're picking up on that word now. That stores a binary state until a high signal appears in the reset. In this case, the flip-flop will retain the state of the temperature sensor until it is reset. The power will thus remain off even when the temperature has risen above 300 degrees, then drop back below 300 degrees. The power will remain off until the system is manually reset. And then there's a cool little video at the end there. And yeah, that's pretty much it. So hopefully that's given you some insight into how flip-flops work. They're quite simple. Pretty much you've got two either NAND gates or two NOR gates, and then the output from the either gate then is looped back into the opposite gate. By having that, it's like a trapdoor. It allows you to store the different states, and then it's until you press the reset button that it's able to get out of that flip-flop structure. So that's it from me. If you did enjoy this video, give us a like and subscribe down below, as it does help with the YouTube algorithm. And yeah, if you have any questions as well, please pop them in. Thanks again. See you next time on STEAM with Steve. Adios.